What's going on, everybody? My name is Alex Freeberg, and in today's video we're going to be starting our Basics of SQL series. Now in this series we're going to be going over everything you need just to get started, and then in future videos we're going to be going over some intermediate concepts and some more advanced concepts, and then in the final series we're going to be going over some portfolio projects. In this video in particular we're going to be downloading SQL Server Management Studio, we're going to be creating our tables, inserting data into our tables, and then in future videos we're going to actually learn how to query those tables. If you already have SQL Server Management Studio downloaded, you can skip ahead to where we actually create the tables and insert the data into the tables. If you don't care about that at all and you're just looking how to query, I would skip to the next video where we actually start querying the data that we inserted into those tables. So to download SQL Server Management Studio, we actually have to download two things, and I have both links right here. I'm going to leave those in the descriptions that you guys have those. But this one is to actually download SQL Server Management Studio. So let's go down here. I actually deleted it off my computer so I could walk through this with you guys. So we're going to download that. Let's also go over here. This is actually a server. So we have to download a SQL Server. And if you go down right here, there's a free version. Now, I don't need the developer version. I'm just going to download the Express version. It's actually smaller. So let's download that as well. Now, once this is done running, we're going to open it up and I'll show you what to do next. So it just finished running. Let's click on it. All right, so we need to install it. We're going to click yes, and this is going to take a little while. So this popped up. I clicked install, and it's been running for the past couple of minutes. Apparently I was not recording, so I apologize for that, but that's all I did. So now it's been installed. I'm actually going to pull it up right here. And let's open it up. Now when it pulls up, it's going to ask you to connect to a server, and that's why we downloaded the SQL Express server. So let's connect to that. And there you go. It's as easy as that. So now we have SQL Server Management Studio set up and we are good to go. So the first thing that we need to do is actually create a database. So let's go over here to databases and let's click new database. And let's just do SQL tutorial. Keep it simple. And if we click that, it's going to create our database for us. Now when you open up the database, there's going to be a lot of stuff. You really do not need to know all this. Really what we're going to be sticking to is this tables right here. As of right now, we do not have any tables, so we need to create tables. Now there's two ways that you can do that. You can click right here and you can go to new and create table. We're not actually going to do that. We're going to create it using a script or a T-SQL. So we're going to go over here and do new query, and we will get started on actually creating the two tables that we're going to be using for all the stuff going forward. All right, so let's get rid of me because we really don't need to be seeing me anymore. Let's get started by doing our very first table, which is going to be our employee demographics table. So let's start off by saying create table, and we have to name it. So let's do employee demographics and enter down. We want to do an open parenthesis. Now we need to specify what our column names are going to be and what the data type is for each column. So let's start off with employee ID, and we want that to be an integer. So that'll be like 1, 2, 3, 4, anything numeric. Now we want to do first name, and let's make that varchar 50. If you don't know what these data types are, that's okay. That will probably be covered in a different video. That's not really necessary for this video. Let's do last name. We'll also make that varchar 50. Let's do age. Make that an integer, and very last, let's do gender, and we will make that varchar 50 as well. So now we have our very first table. Let's run that, and we'll see if it works. We'll go over here, and we'll refresh our tables, and there you go. So we have our very first table. Let's go up here, let's get rid of this one, and now let's create our second table. So we're going to do basically the exact same thing, but we're going to have a little bit different information in it. This is going to be our employee salary table. So let's do create table, and again we need to name it and enter an open parentheses. So now we're going to do the same thing. We're going to do employee ID. Let's make that an integer. Now we want the job title because we want to know what they do. And this one is going to be varchar 50 because we keep it pretty simple. Whoops. And then for our very last one, we're going to do salary, and that will be integer as well. And I'll just do parentheses here. So let's create this table. Let's see if it is there. And there we go. So let's open up one of these tables really quick, see what's in there, see what it looks like. As you can see, we do not have any information in there. When you create a new table, sometimes when you open it up, you're going to see this. If you want to get rid of that, you just need to do I think it's called a hard refresh or something like that, but you can do Control-Shift-R. Let's see if it works for me. I just did it. All right, and it goes away. So now it recognizes it as a table. So we're good there. Let's go back here and let's get rid of all this. We've already created our tables. Now we want to insert the data into our tables. So let's see what that looks like. Let's do insert into, and now we need to specify what table we're inserting our data into. So let's start off with employee demographics. Let's do values. So now we have to select what values we're going to put into this table. So now we're going to have to do the employee ID. So let's do 1001. And then we're going to do first name. So let's do Jim. Last name, Halpert. And then his age, let's say he's 30. And he is a male. Now, just for fun, let's execute that. Let's go back to this table right here and execute. And as you can see, all of our information actually went in there. So now we have his employee ID, his first name, his last name, age, and gender. Now, we need a lot more information for this table in order to actually learn a lot of the concepts of querying the table. So I'm actually going to go through and add a ton more information. I'm not going to bore you through that, but I will show you the final product before I actually hit execute. So stick with me. I'm actually just going to cut to the end where I insert all my stuff down here. And then if you want that, I'll probably leave it in the description or maybe put it in my GitHub or something so that you can easily just go copy and paste that if that's what you want to do. So I'll see you in a few seconds. All right, so I have all my values right here. I actually am going to take this one out because I already did that one. But this is our additional information. Let's insert that into our table real quick and go back here and take a look at it. And there you go. This is going to be our core information that we are querying off of in future videos. So that table is completely finished. Let's go back here. We're going to get rid of this because now we want to insert our information to our other table. So let's do insert into, and let's do employee, and now we're going to do salary. So let's do values to specify that we're inserting values into there. And in this one, we have employee ID. So again, let's do 1001. That's Jim. His job title is salesman. And let's say his salary is $45,000. And let's execute that. And you can't see it, but down here it says it's done. Let's go to that table. And as you can see, that is inserted. I'm going to do the exact same thing as I did before. I am going to fill out all these, and in a second, it will be done on your side. And then again, I will leave it in the description, or I'm going to put it on my GitHub, and you guys can just copy and paste that if that's what you want to do, or you can write it out, whatever you want to do. All right, just like before, I'm going to get rid of this first one. That is Jim. He is already done. Now let's insert this information. It is finished. Let's go back here. And there we go. Now we have both of our tables and we are good to go for future videos. So thank you so much for sticking all the way through this one. In the next video, we're going to actually begin querying the table and learning the select, the from, the where, the group by, and the order by statement. Everything is in these upcoming videos, so stick around and we will learn all of that together. Thank you so much for joining me. If you like this type of content, be sure to subscribe below, and I'll see you in the next video. What is going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be going over the select and the from statement. So if you joined us for our last video, we went over creating our tables and inserting data into those tables. And so we have this employee demographics table, and we also have this employee salary table. And today we're going to be walking through the select statement and the from statement on these tables. So here's some of the concepts that we're going to be going over today. Let's just get it started by doing select everything. And let's do this from the employee demographics table. So let's execute this. If we wanted to only show the first names, we can just do first name and run that. And if we want first name and last name, we can just separate that by using a comma. And it will return those. But if we want to return all columns and all rows, then all we have to do is use this star. So that's what the star does. Now, we have 9 rows of data here. And if we only wanted to return, let's say, the top 5, we can easily do that. And we can just say top 5 of everything. Now, the reason this could be useful is, say you have a table that has millions of rows in it and you only want a small sample, you can say select top 1000. And when you do that, it will only select the top 5 rows. Now let's get everything back in here really quick because we're going to move on to this distinct feature. So when we use distinct, we're actually saying that we want the unique values in a specific column. So if we say distinct, and then let's do employee ID, everything should be returned. So all 9 rows should be returned. And that's because every single one of these are unique. Now let's try gender. So there's only going to be 2 results, the male and the female. And that's because there's only 2 distinct values in that column. Now let's look at all of our data again. So now we want to look at count. Now count is very simple. All it is going to do is going to show us all the non-null values in a column. So let's look at last name, for example. If we do count of last name, all that's going to give us is a count of 9 because we have 9 last names. If for whatever reason somebody's last name was left out and that was null, then it would have returned maybe 8 or 7 depending on how many were actually in there. So if an entire column was null, it would be returned 0. And if you notice, we are not given a column name. That's because this is derived information based off the last name. So if we want to actually give this a name so that that column does not say no column name, we can use this as right here. So once you put as, you can actually name it. So since this is the count of the last name, we'll write last name count. Keep it simple. And if we execute that, as you can see, we have last name count right there. So that's how you use that as. Let's look at all of our data again. We want to look at some max, mins, and averages right now. And the only column here where it would be useful to do it on is age. But let's actually go over and let's look at our salary table. And at our salary table, we have some really interesting salaries that I think would be a little bit more useful for this information. So let's go over to employee salary. All right, and let's look at this table really quick. So we have our salary. Now we want to look at the maximum salary that is in that column, and that is going to be $65,000. Now let's say we wanted to know what the minimum salary was. Let's execute this, and the person who makes the least money is making $36,000. Now what's the average? What is the average salary for all employees? That's going to be $48,555. So super easy to use all of these things. They're extremely useful. I use them every single day. So I know that each of these are very, very useful and are definitely among the basics that you have to know. Let's look real quick at everything really quick. So we just learned the select statement, but learning this from statement really quick is also important. Up here, this actually shows us that we're already hitting off the SQL tutorial database, but let's say we change it to master. When we try to run this, it's going to give us an error. And that's because now we're hitting off this database, and this database does not have this table in it. So in order to do this, in order to still hit off that table while up here we're actually hitting off a different table, we can change this information. So the from statement, you have to specify 3 separate things. The first thing that you need to specify is the database. So let's say we want to hit off the SQL tutorial database. Now we want to select what table we're going to do. This is actually a .dbo. So let's put .dbo. There's a lot that can go into that. It's not worth getting into now, but .dbo and let's do employee salary. When we execute this, our information comes up. Even though up here we're still hitting off the master database, when we specify it right here, then we actually are choosing what database and what table to hit off of, and so it does not matter what it is up here. So that's how you use the from statement. In the next video, we're going to be going over the where statement, and then after that, the group by and order by statement, and that will be the complete basics of SQL tutorial, and then we'll start getting into a little bit more fun stuff, some more advanced concepts, which I think would be really, really exciting for everybody to learn. Thank you guys so much for joining me. I really appreciate it. I hope this has been helpful. If you like this type of content, subscribe below, and I'll see you in the next video. Thanks and goodbye. What is going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be going over the select and the from statement. So if you joined us for our last video, we went over creating our tables and inserting data into those tables. And so we have this employee demographics table, and we also have this employee salary table. And today we're going to be walking through the select statement and the from statement on these tables. So here's some of the concepts that we're going to be going over today. Let's just get it started by doing select everything. And let's do this from the employee demographics table. So let's execute this. If we wanted to only show the first names, we can just do first name and run that. And if we want first name and last name, we can just separate that by using a comma, and it will return those. But if we want to return all columns and all rows, then all we have to do is use this star. So that's what the star does. Now we have 9 rows of data here, and if we only wanted to return, let's say, the top 5, we can easily do that. And we can just say top 5 of everything. Now the reason this could be useful is, say you have a table that has millions of rows in it and you only want a small sample, you can say select top 1000. And when you do that, it will only select the top 5 rows. Now let's get everything back in here really quick, because we're going to move on to this distinct feature. So when we use distinct, we're actually saying that we want the unique values in a specific column. So if we say distinct, and then let's do employee ID, everything should be returned. So all 9 rows should be returned. And that's because every single one of these are unique. Now let's try gender. So there's only going to be 2 results, the male and the female. And that's because there's only 2 distinct values in that column. Now let's look at all of our data again. So now we want to look at count. Now count is very simple. All it's going to do is going to show us all the non-null values in a column. So let's look at last name, for example. If we do count of last name, all that's going to give us is a count of 9, because we have 9 last names. If for whatever reason somebody's last name was left out and that was null, then it would have returned maybe 8 or 7, depending on how many were actually in there. So if an entire column was null, it would be returned 0. And if you notice, we are not given a column name. That's because this is derived information based off the last name. So if we want to actually give this a name so that that column does not say no column name, we can use this as right here. So once you put as, you can actually name it. So since this is the count of the last name, we'll write last name count. Keep it simple. And if we execute that, as you can see, we have last name count right there. So that's how you use that as. Let's look at all of our data again. We want to look at some max, mins, and averages right now. And the only column here where it would be useful to do it on is age. But let's actually go over and let's look at our salary table. And at our salary table, we have some really interesting salaries that I think would be a little bit more useful for this information. So let's go over to employee salary. All right, and let's look at this table really quick. So we have our salary. Now we want to look at the maximum salary that is in that column, and that is going to be $65,000. Now let's say we wanted to know what the minimum salary was. Let's execute this, and the person who makes the least money is making $36,000. Now, what's the average? What is the average salary for all employees? That's going to be $48,555. So super easy to use all of these things. They're extremely useful. I use them every single day. So I know that each of these are very, very useful and are definitely among the basics that you have to know. Let's look real quick at everything really quick. So we just learned the select statement, but learning this from statement really quick is also important. Up here, this actually shows us that we're already hitting off the SQL tutorial database, but let's say we change it to master. When we try to run this, it's going to give us an error. And that's because now we're hitting off this database, and this database does not have this table in it. So in order to do this, in order to still hit off that table while up here we're actually hitting off a different table, we can change this information. So the from statement, you have to specify 3 separate things. The first thing that you need to specify is the database. So let's say we want to hit off the SQL tutorial database. Now we want to select what table we're going to do. This is actually a .dbo, so let's put .dbo. There's a lot that can go into that. It's not worth getting into now, but .dbo and let's do employee salary. When we execute this, our information comes up. Even though up here we're still hitting off the master database, when we specify it right here, then we actually are choosing what database and what table to hit off of, and so it does not matter what it is up here. So that's how you use the from statement. In the next video, we're going to be going over the where statement, and then after that, the group by and order by statement, and that will be the complete basics of SQL tutorial, and then we'll start getting into a little bit more fun stuff, some more advanced concepts, which I think would be really, really exciting for everybody to learn. Thank you guys so much for joining me. I really appreciate it. I hope this has been helpful. If you like this type of content, subscribe below, and I'll see you in the next video. Thanks and goodbye. What's going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be going over the group by and the order by statements. In previous videos, we created tables, we went over the select, the from, and the where, and now we are at the very end of our SQL Basics series. If you stayed with us for the whole time, hopefully you have learned a lot and learned the basics of SQL. In future videos, we're going to be going over intermediate and even more advanced concepts, and even going through portfolio projects that you can use to put on your resume. If you like this type of content, be sure to subscribe below, but let's get into it for today. The group by statement is similar to distinct in the select statement in that it's going to show the unique values in a column. The difference is if we say distinct gender, what's going to be returned is the very first unique value of female and the very first unique value of male. But if we say gender and we say group by gender, it's only going to return 2 values, but in these 2 values, we actually have all the males rolled up into this one row and all the females rolled up into this one row. Now let me further show you what that means. If I say count of gender, now you can see that this whole time there were 6 males in this one row and there were 3 females in this one row. So with the distinct, it really is only showing us what value is in there that's unique. But with the group by, it's showing us what the unique value is, but it's also rolling them all up into one column so that we can use it for other things. Now real quick, I want to be able to see both of these at the same time. So let's just put this up here and let's run this so we can actually see both. Now let's add age to this statement down here, or this query. And let's only run this one. I want to show you what happens and why it happens. We're now looking at gender, age, and then the count of gender. So if we look down here, we only have 1 male who is 29. We have 1 male who is female, that's age 30, and so on and so forth. So none of these people are both the same gender and the same age. If, for example, we had 2 or 3 people who were male and who were 30 years old, then we would have a 2 or a 3 over here. So this count is actually being counted at each row that's being returned. So for our data that we have today, this isn't a fantastic example because it really split it out. There were any that were the same, But as you can see, you can put multiple columns as long as you put multiple down here. Now, why did we not have to put this count gender down here in this group by? That's because this count gender is actually a derived field or a derived column. It's derived based off the gender column. So it's technically not a real column that's in the table. It's one that we're creating that's fictional, per se. So the age and the gender are actual fields or actual columns that are in our table, so they have to be down here. And like I said before, it's the comparison to that distinct in the select statement, because we're looking at the distinct of gender and age. So we're saying distinct across multiple columns, both gender and age. Now, as we had it before, we were only looking at gender. It's going to roll all of those up into just male and female. But if we want to add more, we can easily add more. In this group by statement, we can still do things like where age is greater than 31. We can still do those things. So let's execute this, and our numbers are going to change. Now we're doing it based off gender, and we're looking at the count of people whose age is greater than 31, which is smaller than before. Now let's look at order by. I'll do it down here really quick for demonstration, but I am eventually going to come up here and use it because I think it'll be a little bit better. To completely round out this query down here, let me give this a name. Let's do count of gender, and then let's come down here and let's order by count gender. And when we run that, it's going to do 1, 3. And that's because, as a default, SQL has an ascending feature, which is going to be smallest to largest going down. If we want to change that, we can change it to descending. That's going to be largest to smallest. So now we have 3, 1. And if we want to do it based off gender, and we do it descending, now we have Z to A. And so that's going to be male, female. And if we get rid of that, it's going to do the default ascending. And let's see what that brings. Female, male. Now, for what we're trying to do, let's look at this large table. So I think it's going to be a little bit more descriptive or a little bit better visually. Let's do order by, and let's do age. Let's run this, and it's going to order smallest to largest. If we do descending, it's going to do largest to smallest. Now, you don't only have to do just one thing. You can do multiple columns. So if I wanted to do age and then gender, I can do that as well. So let's do gender. And let's run that. So now we have the age, but under the age, we also have it ordered by female, and that's in ascending order. So A, B, C, D, F, so females first. So it's going to be female first, and then it's going to be male. And again, female and male. Now, we don't have to just let it be ascending for each one. If I wanted to do it reverse in this column, I can do descending. Now let's run that. And when we have 30, now male is first and female is second. And if I wanted to do that over here, I can do descending. And now we have them both descending. So it's going to go top to bottom. And when we have 32, it's going to be male, 32 female. So you can specify lots of different things in here, and we don't actually have to use column names. We could just use numbers. So if I wanted to do 1, 2, 3, 4, 5, I could. But let's try to replicate the exact same thing before. This would be column 1, 2, 3, 4. So let's do where 4 descending, and then let's do 5 descending. And if we execute that, it's going to give us the exact same result as if we'd actually put in the column name. And I do use this a lot. Oftentimes I don't use the column name. If it's a small table, I'll just use the number. So in my actual queries, I do this a lot where I just use the number instead of the column name. So that is the group by and the order by statement. And if you have walked through my previous videos, you should be completely done with the basics of SQL. So congratulations. The next thing to do is really just practice the basics, because the basics are what you're going to be using day in, day out. And so what I would recommend is create a few more tables, query those tables, try to think of use cases and what you would actually want to know from that information. After that, I would move on to my intermediate videos if those are already out, and then I would move on to my advanced videos. Those are going to go over some more challenging topics, but things that would be very useful for anybody to know. In my next video, I'm going to be going over intermediate SQL topics, things like joins and subqueries, and a ton more. So if I already have posted those, be sure to go check those out on my page. And if I haven't, I hope to have those up soon. Thank you guys so much for watching. I really appreciate it. If you learned anything in this Basics of SQL series, be sure to subscribe below, and I'll see you in the next video. What's going on, everybody? My name is Alex Freeberg, and today we're going to be starting our intermediate SQL series. If you joined us for our last series, we walked through the basics of SQL, which is everything you needed just to get started. And in this series, we're going to be walking through some intermediate concepts to really take your skills up to the next level. Now, today we're going to be walking through joins, but let me show you what you can expect from the entire series for this intermediate course. So we're going to be walking through joins today, and then in future videos, we're going to be walking through unions, case statements, updating and deleting data, partition by, data types, aliasing, creating views, having versus the group by statement, the getDate function, primary key versus foreign key, and then we're going to have an advanced course, and this is not set in stone yet, but these are some of the things that I think I will be going through or walking through. We're going through CTEs, sys tables or system tables, subqueries, temp tables, string functions, regular expression, stored procedures, and then importing and exporting data. So with all that being said, let's get into it. All right, now let's get rid of me because we do not need to be seeing me for the rest of the series. At the very top, here are some of the things that we're going to be going through today, which are inner joins and then outer joins. And in the outer joins, we have a few different styles or a few different types of outer joins. Now, a join is a way to combine multiple tables into a single output. For now, we're going to be using the employee demographics and the employee salary table. So let's get a look at both of these tables and see what's in them. In our employee demographics table, we have employee ID, first name, last name, age, and gender. And then down here in our employee salary table, we have employee ID, job title, and salary. If you notice, they have a similar column, and that's going to be the employee ID. Now, when you're doing a join, you have to do this based off a similar column, and typically you want it to be a unique field. So we're going to be using the employee ID from both tables to join these tables together to create one output. So let's get rid of this real quick, and let's start building our query to join these two tables together. So the first thing we're going to do is an inner join. So let's do select everything, and let's do it from SQL tutorial.dbo.employee demographics. And let's do join. We can also say inner join, but join by default is going to say inner. And we're going to do SQL tutorial.dbo.employee salary. Now we have to join them together, which is what we talked about earlier, and we're going to be doing that based off the employee ID. So for that, we have to say on, and then we're going to say employee demographics dot employee ID is equal to employee salary dot employee ID. So let's run this real quick and take a look at the output. And let me pull this up real quick. So what we are looking at is actually both tables combined. We have the employee ID, first name, last name, age, gender, and then here's the salary, employee ID, job title, salary. Now an inner join is really only going to show everything that is the same. So in both tables, there are employee IDs of 1001 all the way down to 1009. But if you notice, there is data that is missing. Real quick, let's go down to this graphic and let's look at this inner join. An inner join is going to show everything that is common or overlapping between table A and table B. So what we are looking at here is exactly that. We're only looking at the things that are similar based off this employee ID in both tables. Now let's change this join to a full outer join. And let's run this and see what we get. Now, if you notice, the output is very different. So let's take a look at it and see why it's so different. if you notice, everything down till here is the exact same. So employees 1001 down to 1009 are exactly the same. But once we get down to row 10, it starts to get very different. Now we are joining these tables based off the employee ID. So for example, right here, Ryan Howard has an employee ID of 1011. But as you can see in this table for salaries, there is no 1011 employee ID. So it has nothing to link it to. So because of that, it fills in everything as null because it has nothing to match on this table. And vice versa, in the employee salary table, there's a person in here that's a salesman and there's no employee ID at all, which means all this information is going to be null. And we can see that in this diagram right here. So this is the full outer join right here. And what it is saying is we are going to show everything from table A and table B, regardless of if it has a match based on what we were joining them on. So even if table A has an employee ID, but there's no employee ID in table B, we're still going to show it, and vice versa. So now let's look at a left outer join. A left outer join is going to take the left table and say we want everything from the left table and everything that's overlapping, but if it's only in the right table, we do not want it. Now, what is the left and the right table? The left table is going to be our first table that we use. Our right table is going to be the second table that we use. So we're going to look at everything in the employee demographics table, regardless of whether or not it has a match on the employee ID in the employee salary table. So this is what that looks like. So as you can see, this is our entire table for employee demographics. And down here, we have 3 that have information in the employee demographics table, but have absolutely no information in any of the employee salary table because there's nothing to match it on. So this 1011 is not in this table. This 1013 is not in this table. And this one does not even have an employee ID. So we're not going to have a match at all. And if we change that to the right, you'll see the exact opposite. It's going to show us everything in the employee salary table. So now we have all of our information right here from the employee salary table. And if it doesn't match in this table, it's just going to have nulls. So down here we have 1010, and obviously there's not going to be anything associated with that because there's no 1010 in the employee demographics table. And for this one, we have a salesman with no employee ID. And since there's no employee ID to tie it to this demographics table, we're going to have nothing. And we can see that in the diagram right here. So for the left outer join, we're looking at everything in table A, which is our demographics table. And in our right outer join, we're looking at everything at table B, which is our salary table. Now let's pull this down a little bit. So far we've only been using the select star. So we've been selecting everything, and I only did that just for demonstration purposes, but you most likely would not be doing this when you actually use these joins. What you're probably going to want to do is select exactly what columns you want in your output. So for example, let's do employee ID. Let's do first name, last name, and let's do job title, and let's do salary. And let's try to run that really quick. And as you can see, it is not going to work. Now, why is that not working? It's not working because we have 2 fields, one in each of these tables, and we have to specify what employee ID we want, because that is going to drastically change what our output is. So we have an employee ID in this table and in this table. Which one do we want to use? So for this demonstration, let's use employee demographics.employee ID. And let's actually just do an inner join because it's easier for the output. Now let's run this and see what we get. So as you can see, we now have the employee ID, first name, last name, job title, and salary. Now we're doing this with an inner join based off the employee ID from the employee demographics table. But if we use the employee salary table, it should give us the exact same output. And that's because we're using an inner join. And an inner join is only going to show us everything that overlaps between both tables. But now let's try a right outer join. And let's run this. Now we're using this employee ID from our employee salary table. And since we're doing a right outer join, we're going to get all the information from our employee salary table, and it does not have to be in our left table, which is our employee demographics table. So if you look at the information down here, this 110 is in the employee salary table, but it's in this position because that's what we're looking at in our select statement. And then over here, we have our salary. And since we have information right here, which is in our employee salary table, but there is no employee ID, our employee ID is null. Now let's change this to look at the employee demographics employee ID and execute it. As you can see, that 110 is gone. Now we just have this information right down here, and we didn't have the employee ID for either of these, so it's going to show it regardless, and that's again because we have a right outer join, and that's why we have no employee ID down here. Now let's do a left outer join, and it's basically going to do the opposite of what we just looked at. Now we're looking at everything from our left table, regardless of if it's in our right table. And so our left table is our employee demographics table, and we are looking at our employee demographics ID. So with the employee demographics ID, it's going to show us the first name and the last name, which is everything in our left table, our employee demographics table. And since for these IDs, or lack of IDs, it's just going to give us nulls in all of these places. If I change it right up here to the employee salary employee ID, and I execute it, because we're showing everything from our left table, which is our employee demographics table, we are still going to see our names. But since we're using the employee ID from our right table, now we're just going to have blanks in this information and this information. Now let's look at a use case for these joins. Let's say Robert California is pressuring Michael Scott to meet his quarterly quota, and Michael Scott is almost there. He needs like $1,000 more, and he comes up with the genius idea to deduct pay from the highest paid employee at his branch besides himself. So how does he go about doing this and identifying the person that makes the most money? Well, of course, he's going to come to SQL first. So we actually want to look at a full outer join real quick, and let's just look at everything. So here's what we have. We have the employee ID, first name, last name, age, gender, employee ID, job, title, and salary. Now, what information do we need to know to get the information that Michael Scott needs? Well, we need the employee ID. We want the first name and last name. So let's write all that real quick. So employee ID, we need first name, we need last name, and then we're also going to need the salary because we need to know who is the highest paid employee. So now let's do an inner join because we really only want to look at the employee IDs where we know what their name is and their salary is. And let's do this based off the employee demographics table. Really doesn't matter for an inner join, but let's do that real quick. So let's look at this. So we have our employee ID, we have our first name, our last name, and our salary. And we want to do it where it's not Michael Scott. And that's because Michael doesn't want to take away his own money, he wants to take away his employee's money. So let's do where first name does not equal Michael, and he knows that he's the only one that is not named Michael. So now we have our list, and let's do order by, and let's do salary. And let's execute this. And let's do descending so that we can get at the very top. And this is tough news for Dwight Schrute because it looks like he is the highest paid employee besides Michael. And so it looks like he is going to get a cut in his pay this quarter so that Michael can meet his quota. So that's just one use case. Let's look at one more use case. Let's start out by getting rid of this and looking at everything again. So for our next use case, Kevin Malone, who is an accountant, thinks that he may have made a mistake when looking at the average salary for our salesman. Now, Angela Martin is very good at SQL, and so what she is going to do is she wants to go in and calculate the average salary for our salesman. So let's try to get that information. So all we're going to need is the job title and the salary. So let's come up here And let's get job title, and let's get salary, and let's look at this. And now we only want to look at where the job title is equal to salesman. Now the very last thing we want to do is we want to say we want the average of salary. Now, since we're going to need to do a group by, we're going to have to get rid of this salary and just take job title right down here and do group by job title. So we're going to have job title and then the average salary. And there you go. We have the salesman and the average salary is $52,000. So Angela now knows to go back and fix what Kevin made a mistake on. So that's how you use joins. I will include this image in the description so you can go and look that up yourself if you are curious and want to look at that. That really helped me out when I was first getting started to kind of conceptualize and understand what kind of data I was pulling based on what join I was using. So I hope that was useful to you as well. In the very next video, we're going to be looking at the union. So if that is posted, be sure to check that out next. Thank you guys so much for joining me. I really appreciate it. If you like this type of content or got anything out of it today, be sure to smash the like button, smash the subscribe button, and I'll see you in the next video. What's going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be looking at unions. Now, in the very last video, we walked through joins, and I thought it was appropriate to look at unions next because unions and joins are somewhat similar or closely related. And that's because in both instances, they're combining two tables to create one output. Now, what's the difference? The difference is that a join combines both tables based off a common column. And in the last video, that was the employee ID. So in both tables, we had an employee ID. And when you're selecting your data, you have to choose either to only select one employee ID, or you can choose both employee IDs, but they're in separate columns. And with a union, you're actually able to select all the data from both tables and put it into one output where all the data is in each column and not separated out, and you don't have to choose which table you're choosing it from. Now that may not have made 100% sense, but let's look at it real quick in stages. So let's go down here and let's actually join this table together and see what we get. Now the two tables that we're looking at is employee demographics and warehouse employee demographics. So over here, we have our employee demographics information. And then over here, or actually down here, we have our warehouse employee demographics. Now, right now I'm doing a full outer join. So we're looking at all the data. And if we were to pull this in to an Excel spreadsheet, we could just copy this and paste it over here and we would be good to go. And that's because we have all the same columns. First name, last name, age, gender, first name, last name, age, gender. But if we tried to combine this in a query where we had this information right here, it wouldn't work. We cannot get it in the same column, and that's where a union comes into play. So let's go back up here and let's actually run both of these. Now, as you can see, they have the exact same columns, and that makes it super easy for what we're about to do. All we're going to do is between these two queries, which are completely separate right now, all we're going to do is write union. So let's run just this. Now, because of the union, you can look down here and the information that used to be in the other table, which were in separate columns, are now added down below in the exact same order. Now, Daryl Philbin was actually in both tables. And the reason he isn't showing up multiple times is because this union is actually taking out and removing the duplicates, kind of like a distinct statement. Now, there's actually another thing called union all, and if we do union all, it is going to show us all of the information regardless if it is a duplicate or not. So let's run that real quick, and they are both there, but let's order by, and let's do employee ID. So now let's run it. And as you can see right here, these are exact duplicates. And so the union got rid of it because they were the exact same, but the union all kept it in because it is showing just the data as is. Now let's get rid of this union all because the only reason why it works so well is because those two tables were the exact same. They were employee ID first name, last name, age, gender. So they're basically the same tables just with different information. So it made it really easy. But we have another table, employee salary. And let's look at these two tables. So these two tables are obviously very different. They hold different information. Now we would still be able to combine them. So let's do employee ID, first name, and let's do age. Now down here on the employee salary table, we will do employee ID, job title, and salary. Now let's use a union really quick and run this one. And it is still going to work. Now, why does this work? Well, first off, the reason it's working is because these data types are the exact same, or at least similar. So text and text, age, which is an integer, salary, which is an integer. It has the same amount of columns. So 3 and 3. So we have employee ID, first name, and age, and it's taking that from the first select statement. And it's still using a union to take the data from the second select statement. So it's still inserting this information. Now this is not what you want to do, because right here we have first name and it's salesman, salesman, and then our age we have 30, 45,000, and 45,000 is obviously not an age. So you want to be careful when you're using a union to combine two separate tables and make sure that the data you're selecting is the same. In the very next video, we're going to be walking through case statements. Thank you guys so much for joining me. I really appreciate it. If you like this type of content, be sure to subscribe below, and I'll see you in the next video. What's going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be looking at unions. Now, in the very last video, we walked through joins, and I thought it was appropriate to look at unions next because unions and joins are somewhat similar or closely related. And that's because in both instances, they're combining two tables to create one output. Now, what's the difference? The difference is that a join combines both tables based off a common column. And in the last video, that was the employee ID. So in both tables, we had an employee ID. And when you're selecting your data, you have to choose either to only select one employee ID, or you can choose both employee IDs, but they're in separate columns. And with a union, you're actually able to select all the data from both tables and put it into one output where all the data is in each column and not separated out, and you don't have to choose which table you're choosing it from. Now that may not have made 100% sense, but let's look at it real quick in stages. So let's go down here and let's actually join this table together and see what we get. Now the two tables that we're looking at is employee demographics and warehouse employee demographics. So over here, we have our employee demographics information, and then over here, or actually down here, we have our warehouse employee demographics. Now, right now I'm doing a full outer join, so we're looking at all the data, and if we were to pull this in to an Excel spreadsheet, we could just copy this and paste it over here, and we would be good to go. And that's because we have all the same columns: first name, last name, age, gender, first name, last name, age, gender. But if we tried to combine this in a query where we had this information right here, it wouldn't work. We cannot get it in the same column, and that's where a union comes into play. So let's go back up here and let's actually run both of these. Now, as you can see, they have the exact same columns, and that makes it super easy for what we're about to do. All we're going to do is between these two queries, which are completely separate right now, all we're going to do is write union. So let's run just this. Now, because of the union, you can look down here and the information that used to be in the other table, which were in separate columns, are now added down below in the exact same order. Now, Daryl Philbin was actually in both tables. And the reason he isn't showing up multiple times is because this union is actually taking out and removing the duplicates, kind of like a distinct statement. Now, there's actually another thing called union all, and if we do union all, it is going to show us all of the information regardless if it is a duplicate or not. So let's run that real quick, and they are both there, but let's order by, and let's do employee ID. So now let's run it. And as you can see right here, these are exact duplicates. And so the union got rid of it because they were the exact same, but the union all kept it in because it is showing just the data as is. Now let's get rid of this union all, because the only reason why it works so well is because those two tables were the exact same. They were employee ID, first name, last name, age, gender. So they're basically the same tables just with different information. So it made it really easy. But we have another table, employee salary, and let's look at these two tables. So these two tables are obviously very different. They hold different information. Now we would still be able to combine them. So let's do employee ID, first name, and let's do age. Now down here on the employee salary table, we will do employee ID, job title, and salary. Now let's use a union really quick and run this one. And it is still going to work. Now, why does this work? Well, first off, the reason it's working is because these data types are the exact same, or at least similar. So text and text, age, which is an integer, salary, which is an integer. It has the same amount of columns. So 3 and 3. So we have employee ID, first name, and age, and it's taking that from the first select statement. And it's still using a union to take the data from the second select statement. So it's still inserting this information. Now this is not what you want to do, because right here we have first name and it's salesman, salesman, and then in our age we have 30, 45,000, and 45,000 is obviously not an age. So you want to be careful when you're using a union to combine two separate tables and make sure that the data you're selecting is the same. In the very next video, we're going to be walking through case statements. Thank you guys so much for joining me. I really appreciate it. If you like this type of content, be sure to subscribe below, and I'll see you in the next video. What is going on, everybody? My name is Alex Fieberg, and today we're going to be looking at the having clause. Now, the having clause I feel is a little bit unappreciated in the SQL community. I feel like it doesn't get a lot of love, and so today I want to describe how to use it and what it's used for. So before we use the having clause, I want to set up our query here. We want to use an aggregate function in the group by statement, and then I will show you how to use this having clause. So let's look at the job title, and let's look at the count of job titles. And then down here, we need to do group by job title. And let's execute this. And here is our job titles, and here's the count of how many people have those job titles. So now let's say we want to look at all the jobs that have more than one person in that specific job. So let's do where the count of job title is greater than 1. And let's run that. And as you can see, we're going to get this message right here. Now let's read it. An aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list, and the column being aggregated is an outer reference. What that is basically saying is we cannot use this aggregate function in the where statement. We need to use a having clause. So let's get rid of this, and let's say having the count of job title greater than 1. I did the same thing again. And let's execute this, and we're still going to get an error. Now, why are we getting that error? The reason is because this having statement is completely dependent on the group by statement, because we are performing this after it has been aggregated. So this having statement actually needs to go after the group by statement, because we can't look at the aggregated information before it's actually aggregated in that group by statement. So now let's run this, and it worked perfectly. So now we only have the jobs that have more than one employee for that job title. So now let's look at one more example. Let's do the average, let's say salary, and let's get rid of this having clause real quick, and just to look at this information, and let's do order by, and we'll do average salary. So let's look at this, and we have 36,000 to 65,000. So in the middle we got 44,500. So let's use this halving statement, and let's say the average of salary where it is greater than 45,000. And we actually need to put this right here, right after the group by and before the order by. So let's run this and see what we get. And it works perfectly. So now we're looking at the job titles that have an average salary of over $45,000. So there you go. That is the halving clause. Definitely one that is good to know and is very useful in specific situations. Thank you guys so much for watching. I really appreciate it. If you liked this video or learned anything today, be sure to subscribe below, and I'll see you in the next video. What is going on, everybody? My name is Alex Freeberg, and today we're going to be looking at updating and deleting data in a table. Now, what's the difference between inserting data into a table and updating data? Insert into is going to create a new row in your table, while updating is going to alter a pre-existing row, while deleting is going to specify what rows you want to remove from your table. So let's get going with the updating. So down here, Holly Flax does not have an employee ID, age, or gender. Now we want to update this table to give her that information. So let's do update. Now we need to specify what table we are going to be hitting off of. So let's do SQL tutorial.dbo.employee demographics. So now we're going to use something called set. And set is going to specify what column and what value you actually want to insert into that cell. So let's set her employee ID equal to, and it's going to be 1012. And we have to specify which one to do this to, because if we ran just this, it's going to set every single employee ID to 1012, because we haven't specified that we only want Holly Flax's row to be updated. So now we have to specify where first name is equal to Holly and last name is equal to Flax. So now let's run this and see what we get. So one row has been affected. Let's see what we got, and there we go. As you can see, the employee ID was updated exactly how we specified it right here. So we also want to update age and gender, and let's do that in the same query. So let's set the age equal to 31. And instead of using and, we actually need to use a comma. So let's say age equal to 31, comma, gender is going to be equal to female. And let's run this and see what we get. There you go. Now let's look at our table. And as you can see, it was updated to 31 and female. So very easy to specify what you want. Oftentimes, tables like this will have a unique key, like employee ID is our unique key in this table. So I could easily just say where the employee ID is equal to, and then 1012. So it's an easy way to specify what employee you're trying to update. So now let's look at the delete statement. The delete statement is going to remove an entire row from our table. So let's do delete. And we actually need to say from, and we have to specify what table we want to be removing this information from. So let's do SQL tutorial.dbo.employee demographics. And now we need to specify what row we want to remove. So let's do where employee ID is equal to, and let's choose a completely random employee ID, 1005. So let's run this and see what happens. So one row is affected. Let's look at our table. And as you can see, 1005 is now gone. Now you have to be very careful when you use the delete statement, because once you run it, you cannot get that data back. There's no way to reverse a delete statement. So if I had gotten rid of this where statement and I ran this, it would delete everything from the entire table and you could not get that data back. So a little trick that I use before I actually run a delete statement is I make it a select statement, because you're going to select everything where the employee ID is equal to, let's just do 1004. And now when you run this, you are going to see exactly what you will be deleting. And now we know that Angela Martin, that entire row is going to be gone. If I hadn't done that and I just went like this and I wrote delete and I only had this running, I would not know that this information is going to be the only one that's gone. Maybe I made a mistake down here. Maybe I accidentally put something in there that wasn't supposed to be in there, and now I'm deleting much more than I thought I was actually going to delete. So using the select statement can be a very good safeguard against accidentally deleting data that you do not want to delete. So that is update and delete. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to subscribe below, and I'll see you in the next video. What's going on, everybody? My name is Alex Freeberg, and today we're going to be talking about aliasing. Now, all aliasing really is temporarily changing the column name or the table name in your script, and it's not really going to impact your output at all. Aliasing is really used for the readability of your script so that if you hand this off to somebody or somebody comes behind you and starts working on this, they can more easily understand it. And it may not sound super useful, especially for small scripts like what we have on the screen. But when you start getting to larger scripts where you have 6, 7, or 8 joins, and you're selecting 10 different column names, it actually is very useful and very important. So let's get into how that actually works, and then I'll have an example later of how we can use aliasing with a little bit of a larger query. So in this table, let's select first name and execute. What we want to do is just write as, and let's do fname. And all that's going to do is it's going to rename this column from first name, which it was originally named, to fname. Now you can use as, but you can also just get rid of that and do it exactly how I have it, and it's still going to work perfectly. You can either use the as or you can not use it. I typically don't, and I just put a space in between the actual column and the alias. Now let's look at an example of how this might actually be useful. So we have a first name and a last name in this column, so what we're going to do is actually combine those. So let's do plus, and let's add a space in there, and let's do a plus, and let's do last name. So this is going to take the first name, add a space, and then do the last name, and we're going to do that as, and let's do full name. And let's execute this. So now we have a column called full name, which is our alias. So we've combined the first name and the last name column into one single column, and we've renamed it full name. If we had not used this alias at all, it would have just said this, which is no column name at all. We don't typically want that when we have an output. We want to give this column a name so that somebody who's actually looking at the script or who's looking at the output of the script actually understands what is contained within this column. So for that, we're just going to keep it as full name. Now, another time that you're often going to use aliasing in the select statement is when you're using aggregate functions. So in this table, we have age. So let's pull that up really quick. So we have age right here, and let's actually just do the average age. And when we execute this, we're going to get no column name and 31. So what we want to do is give it average age. And when we do that, we now have a column name. And again, you want to have a column name in case someone comes up behind you and is reading the script so that they understand what this column is being used for. Now that we've looked at aliasing column names, let's look at aliasing table names. It basically is the exact same thing. We're just going to write as, and let's do demo for demographics. And let's do demo dot, and it's going to give us all of our options, and we'll do employee ID. So when you alias in a table name, when you are selecting in the select statement, you actually need to preface your column name with a table name or the table alias dot and then employee ID. And this is extremely important to do, especially when you have a lot of joins that you're doing, or you're selecting a lot of columns when you have several joins, because it can get very, very messy quick. So let's actually join this to employee salary, and let's do that on demo dot employee ID is equal to sal dot employee ID. So now let's do demo dot employee ID comma sal dot, and let's do salary. So looking at the script now, it is very clean, it is very easy to understand, and that is what's so important with aliasing. If, for example, we took this off, every time we wanted to reference this table, we would have to put the entire table name. And putting the entire table name is correct, it just is very cumbersome and does not look clean at all. And so using something like demo as an alias makes it a lot more easily readable and a lot more manageable when you're looking at it when you have a very long script. Let's look at this query where we're joining together 3 separate tables. And after each table, we have an alias. For employee demographics, we have A, employee salary, we have B, and warehouse employee demographics, we have C. Now, unfortunately, I have seen a lot of scripts that look exactly like this, and this is what you do not want to do. You do not want to use your aliasing to just write an A, a B, or a C. That is very frowned upon when writing queries because it really doesn't give any context to what the table that you're referencing is, and it gets really confusing as this query continues to grow. And as you add more columns to your select statement, it makes it more difficult to understand where those columns are coming from. And so when I'm reading that, I say select a.employee ID. Okay, what's A? A is employee demographics. So you really do not want to do that. Now let's look at an example of what it should look like. So for employee demographics, instead of having an alias of A, I used demo for demographics. For employee salary, I used sal, and for warehouse employee demographics, I used where. Now this is not perfect by any means, but in the select statement, if you're just glancing at it, you can easily understand which columns are coming from which tables. So when I look at employee ID, I know that's coming from employee demographics because I have demo as the alias. So it's a lot easier to understand, and when you hand this query off to somebody, it is going to be a lot easier for them to read through it and understand where those columns and those table names are coming from. And so they will appreciate that in the long run. So that is all I got. That is aliasing. Again, not a super tough subject, but a really important one to understand, especially as you start working in teams and as you start creating more and more complex queries. You want to have it more organized and more easily readable. And so it may not come into play with those really simple queries, but again, as you build out those more complex queries, this becomes very useful. I really hope you enjoyed this video. If you did, be sure to comment and subscribe below. Thank you so much for watching, and I'll see you in the next video.
What's going on, everybody? Welcome back to another intermediate SQL tutorial. Today we're going to be covering partition by. Now, partition by is often compared to the group by statement, but the group by statement is a little bit different. The group by statement is going to reduce the number of rows in our output by actually rolling them up and then calculating the sums or averages for each group. Whereas partition by actually divides the result set into partitions and changes how the window function is calculated. And so the partition by doesn't actually reduce the number of rows returned in our output. Let's get started to look at the actual syntax of how to use partition by, and then we'll compare it to the group by statement later, just to see the differences between the two. We're going to be using these 2 tables on our left over here. So I'm going to pull those up really quick. So let's run this and let's look at the these two tables side by, well, one underneath the other really quick. So what we're going to be using to demonstrate the partition by is this gender column as well as this salary column. And so we just need to join these 2 tables together on the employee ID, and then we'll go from there. Now, I'm not going to bore you with that. I'm going to skip ahead and we'll actually look at how to use this partition by. So I've joined these 2 tables together and this is our output, but we don't want every single column. I'm going to start selecting some of these columns and then we'll start using this partition by and see what the output looks like after that. All right, so let's go right up here. Let's choose the first name. Let's do the last name. We'll do gender and let's do salary. And now we want to identify how many male and female employees we actually have. And so we're going to say count of gender, and this is going to be over. And now we're going to do our partition by, and we're also going to partition that by the gender as total gender. Now I'm going to come back to why we did each part, but I want to see the output first, and then I'm going to come back to why we wrote it this way. So let's just do this really quick. So it's going to be a little bit different than what you typically would expect in a group by statement. The group by is going to roll everything up, and you typically wouldn't have like a first name, last name in a group by statement because it would be very hard to roll all those things up into those individual columns and to reduce the number of columns that are in your output. And so in our output, we can see Pam Beasley. She's a female. She makes $36,000 as a salary. And there are 3 total women that work alongside her in this employee demographics table. And so in our total gender column over here, this is where we use the partition by. And if we used a group by statement to get this kind of information, all we would be able to do to get this information in a group by statement is say select gender, count of gender, and then group by the gender down below underneath the join. So because we're using the partition by, we're able to isolate just one column that we want to perform our aggregate function on. And so we're able to add things like the first name and last name columns, even though we aren't trying to include that in any partition or group by statement, yet we're still able to add the aggregate function to each individual row while still maintaining those other columns. Let's take this entire query and let's basically just transform it into a group by statement. And we'll see kind of what that looks like and what the difference is. So all I'm going to do is get rid of all this. I'm going to copy all of this, and I'm going to say group by, and I'm going to do that because we have to use all these columns in our group by statement. So let's execute this. And as you can tell, we are not able to see the output for the aggregate function that we were hoping for. If we wanted to get the same output that we had before, where we're showing 3 for females and 6 for males, what we'd have to do is get rid of this first and last name and the salary, and do the same thing in the group by statement. And so let me get rid of these really quick and run this. And so what the partition by is doing is basically taking this query right here and sticking it on one line in the select statement. And so I hope now you can see how valuable the partition by can be if used correctly. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. What's going on, everybody? Welcome back to another SQL tutorial. Today, we're going to be talking about CTEs. A CTE is a common table expression, and it's a named temporary result set, which is used to manipulate the complex subqueries data. Now, this only exists within the scope of the statement that we were about to write. Once we cancel out of this query, it's like it never existed. A CTE is also only created in memory rather than a tempdb file like a temp table would be. But in general, a CTE acts very much like a subquery. And so if you know how to do subqueries, you should be able to pick up on CTEs fairly easily. So let's get started writing our very first CTE. We're going to come down here, and we're going to say with, and we're going to write CTE underscore employee. And we're going to say as, and this is where everything's going to start. Now, CTEs are sometimes called with queries. I've never personally used that, but I've seen it called that online. But that's because it uses this with statement right at the very beginning. So now we have with CTE employee as, and then we have an open parentheses. And now we have to construct our select statement. And this is kind of where we build out our quote unquote subquery. And so I'm going to take in a select statement that I actually used in a previous video where we were using the partition by. And so I'm going to put that in there, and I'm going to kind of walk us through what that does and how we're going to use this. So I'm going to paste this down right here, and I'm actually going to go like this just to make it look a little nicer. And then I'm going to close the parenthesis at the end. So now we have our CTE in place. And as you can see, it is basically just a select statement within the with CTE employee as. And what this is going to do is going to take the first name, last name, gender, and salary. And then it's going to take this aggregate function with the partition by, aggregate function with the partition by, and it's going to place it to where we can now query off of this data. So it's putting it basically in a temporary place where we can then go and grab that data. So all we're going to do at the very bottom is we're going to say select everything, and we can do that from CTE employee. So let's run this entire thing and see what we get. So as you can see, this select everything from CTE employee, we are selecting everything from this select statement. And so this feels a lot like a temp table. We were actually querying off of a temp table, but it actually acts a lot more like a subquery. Now we don't have to do the select everything. We can just do first name, and let's do average salary. And when we run this, we'll just get those two columns, and we don't have to go through and actually write this out each time. It's just in this CTE for us. So it does all the heavy lifting within the CTE, and then we can just query off of what we want. Now, something to note is that the CTE is not stored anywhere. And so it's not stored in some temp database somewhere. If I try to run just this by itself, it is not going to work. So let's try that out really quick, and we should get an error. And that's because each time we run this query is actually creating the CTE again. And so it's not being saved anywhere. And so each time we run it, we have to run it with the entire CTE. Another thing to note is you actually have to put the select statement right after the CTE. If I try to go down here and say select everything from, let's do CTE underscore employees, it doesn't actually work. It's not going to come up at all. And that's because it only is going to work with the select statement directly after the actual CTE that you've created. I hope this was helpful, and I hope that you understand how to use a CTE a little bit better. Again, you don't have to go super complicated with the select statement within your CTE. It can be very, very simple. I just wanted to demonstrate that you can use aggregate functions within your CTE and then just query off of those without having to do the aggregate function again, which I find is very, very useful. Again, thank you for watching. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. What's going on, everybody? Welcome back to another SQL tutorial. Today we are looking at temp tables. And if you can guess it based off of the name, they're kind of like temporary tables. And we create them very much the same way. We're going to do create table. It's just a little bit different. And you can hit off of this temp table multiple times, which you cannot do with something like a CTE or a subquery where you can only use it one time, or with a subquery, you need to write it multiple times within a query. And so these temp tables are extremely useful. I'm going to kind of talk about how you can use them as we're going throughout this video. But let's get started right away with actually creating one, looking at it, inserting some data, and kind of showing you how temp tables work and what we can do with them. So we're going to start off with create table, much like a regular table is created. The only difference is we're going to do this £, and then we're going to do temp _ employee. So literally the only difference between a regular table and a temp table is this right here at the very beginning, this £. So let's just start by doing employee ID. We'll make that an integer. We'll do job title, and we'll make that a varchar 100. And then we'll do salary. And let's make that an integer. And so now we have our temp table. Let's go ahead and create it. So now we have our temp table created, and so we can look at it really quick. So let's select everything from, and we'll do temp employee. So let's take a look. It's completely empty. And we can insert data very much the same way we'd insert data into a regular table. So let's start doing that. Let's do insert into, and we'll do temp employee, and we'll do values. And let's just do something really quick, because I'm going to get to a little bit more interesting stuff in a second. Oops. So we'll make this person HR. That's their job title. And then for salary, we'll give them 45,000 and close it off. So let's run this, and let's select everything again and see what's in there. Perfect. So we were able to insert data into this temp table. And again, we don't have to create this every single time or we don't have to run this every single time we need to hit off of it like we did a CTE, if you watched my previous video. In this one, we can just run it and it sits there. And so again, it feels very much like a real table, and I'm going to get to a little bit of the nuances of the differences between a regular table and a temp table in a second. But let's really quickly, we want more data in there. You don't have to just do it value by value. We can also just do where we select all of the data from a specific table and insert that into a temp table. And that is really quickly, how I do it most of the time. Most of the time, I'm not inserting values. I am, taking a large table and taking a subset of that and then sticking it into a temp table. So let's look at this really quick and run that. So now we took all of the data from employee salary, and then we just stuck it into this table. And really quickly, this is one of the big uses of a temp table. We had, let's say, for example, that this employee salary table had 1 billion rows, or just an extremely large number. And we were trying to, hit a somewhat complex query off of it, where we're using joins and we're using maybe some window functions or different things. It would take a very long time to hit off of this. But what we can do is we could insert that data into this temp table, and then we can hit off the temp table, and it already has that subsection of data that we're wanting to use for all of our later queries. So really quickly, that's kind of a use case for that. So let's go down here. We're going to kind of create another one. And this one's going to be a little bit more advanced and a little bit of how I would actually use a temp table. Above was just kind of showing the basic syntax, how you kind of put data into it, kind of how it's used. Now I'm going to show you kind of how I would actually use it. So let's do create table. Let's do temp. Oops. create table. Let's do temp employee 2. And then let's do open parenthesis, and we'll do job title, and we'll make that a varchar 50. And then we can do employees per job. We'll make that an integer. Now we need average age, make that an integer. And the very last one will be average salary. I'll make that an integer as well. And let's run this. Oops. So we have our second table. Now we want to insert data into this one. So we're just going to do insert into, and we'll do temp employee 2. And for this one, I'm going to take a query that we used in a previous video. And so I'm just going to copy and paste that to save time, and then we'll keep on moving from there. All right, so I'm just going to paste that in. We will run this, and really all it's doing is from these tables, it's taking the job title. We're getting a count on the job title, average age, average salary, and that is it. So let's see if that worked, which it looks like it did, but let's actually take a look at the data. And so now we have this subsection of data from this join above. And what this is going to do is whenever we want to run this, we don't have to run it on these two tables and create the join and then do the calculations, which takes time. What it's going to do is it's going to take these exact values and place this into this temporary table. And if we want to run further calculations on these values, we can easily do that in a fraction of the time instead of having to run this every single time, which will take up so much processing power. And it will reduce your runtime dramatically when you're placing this data in this temp table and hitting off of that instead of all these joins and everything above. A lot of times these temp tables are used in stored procedures. Now, if you haven't learned about stored procedures or used stored procedures at all, that's okay. I still want to show you something that might be useful, although this is used a ton in stored procedures. So for example, let's say we have a stored procedure set up. We run the stored procedure and we get an output, and we, for whatever reason, want to run it again. And when we run it again, we get this error. And this temp table lives somewhere. It doesn't live in the actual database, but it lives somewhere. And so when we run it again, we get an error because there's already a temp table created. One trick or one little tip that I would give is doing something like this, saying drop table. Oops, I don't know why I did so many spaces. Drop table if exists. And we'll do temp employee 2, just like that. Now, what this is going to do is when you're running that stored procedure over and over and over again, you're getting an error or whatever. For whatever reason, you need to run it multiple times. Every time that you run it, it's going to encounter this. And so if that already exists, it is going to delete that table and then allow you to create it again. And this is just a really good thing to do. So now if you see down below, I can run this time and time and time again, and it is going to work every single time because it is checking to see if that exists. And if it does, it deletes it, and then I can create again. And so that is just a helpful tip if you're going to try to use this. I highly recommend adding that to your query just to make sure things run smoothly. I know there is a lot more that can go into temp tables, a lot more of the technical aspects or the DBA stuff. Obviously, I just want to teach you how to use it and what you might use it for and how to actually write it out. But there are a lot more things that you can do research on about processing speed and storage. But unless you are something like a DBA, you probably don't need to worry about those things. And so if you are a DBA, I do recommend looking into those things, making sure you understand how that works, how this data is stored, so that when people use them or you are using them, you know what's going on in the background. But for getting up and running with temp tables, I hope that this was helpful. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. What's going on, everybody? Welcome back to another SQL tutorial. Today, we're going to be looking at string functions. Some of the things that we're going to be looking at are things like trim, replace, substring, and upper and lower. We're going to create a new table, insert a little bit of bad data into it, and then we're going to be using that to work on our string functions today. So I already have this set up right here. I'm going to put this in the GitHub so that you can just download this. You don't have to, type this out manually. So go look in the description if you just want to get that off the GitHub and download that and copy and paste it, save you a little bit of time. But let's go ahead and run this really quick. And as you can see in this table, we have our data right here. Give me 1 second. So in this employee errors table, basically what we have, actually, let me pull this back up. Basically what we have is in this first one, we have, here we go. We have some basically blank spaces on the right side. And the second one, some blank spaces on the left side. We also have Jimbo, which is an error because his name is Jim, and Halbert because his name is actually Halbert. And then for Toby, for whatever reason, that O is capitalized. And then Michael got in here and added this extra part. So we're going to have to figure out a way to take that out when we're doing our query. And that'll come in a little bit later, I think, in the substring section. So let's get into it right away. Let's start using our left trim and right trim. And we're going to kind of go through each one pretty quickly, hopefully. I'm not trying to make this a super long video because we got a lot of things to get through in this one video. So I'm going to go through the trim, right trim, and left trim. Let's look at the employee ID because that's the one where we have some blank spaces on the right and the left side. The left side, you'll be able to, obviously, you're going to see that one much easier, but let's start walking through this. So let's do select employee ID. And before we get any further, let me just get the employee errors on here so we can, so that we can see everything as it comes up. So we're just going to do trim and then type in the column that we want to take these blank spaces out of. That's what the trim does. The trim gets rid of blank spaces on either the front or the back or the left and the right side. So on both sides, that's what trim does. And we'll say as ID trim. So let's run this one really quick. And as you can see, this is our regular employee ID. And so, you can't visually see it as easily on this first one, but there are blank spaces after this 1001. And we got rid of those. And then there were blank spaces before the 1002, and we got rid of those. Now I'm just going to copy this 2 times because it's basically the exact same thing, but I'm going to show you them all at the same time. So it's the exact same thing except L trim and right trim. And let's take a look at all these at the same time. And let me pull it up. So in the let me see if I can get these all in here. Okay. In the trim, it got rid of both the left and the right side. So all of these were fixed. In the employee ID for the left trim, we're only going to be getting rid of this one. This one still has blank spaces on it. And when we do the right trim, we're only going to get rid of the stuff on the right side. So this one doesn't change because this is on the left-hand side where the blank spaces are. So this one was fixed. Again, it's not super visual, so you can't really see it, but that one is fixed. Let's move on to the next part, which is using replace. So for this one, we're going to be looking at the last name. So let's go back up really quick to the employee errors. As you can tell, the last name, the biggest one where we kind of want to take something out of because we don't want that, that dash fired still in there. We're going to replace that. And so let's look at how to do that. Let me just copy this real quick and get rid of this top part. So we're going to do the last name. So let's just start off with our last name. And then just as a baseline so we can see what it looks like before. And then we'll do replace. And all we're going to specify is the column that we want to do the replacing in. We're going to specify the value that we want to replace. So in this, it's going to be dash fire. Oops, got a little aggressive on that one. Dash fired. And we're going to indicate what we want to replace it with. Now I'm just going to replace it with blank. And we can say as last name fixed. So let's see what this looks like really quick. And it looks like it worked. So in this last name, it originally had Flenderson-fired. And when we replaced it, and we took that -fired and replaced it with basically nothing, it then fixed it. And so now it looks correct. All right, let's move on to the next one. I think this one might be the longest one to write, but that is the substring. And let me take this real quick, trying to save us some time. So substring is very, very unique. You can specify in either a number or a string, you can specify the place that you want to start. And then you can also specify how many characters you want to go out. And it pulls that in. So just as a really quick example, and then I'm going to show you kind of a use case for this one that I think is pretty cool that, maybe, let me see. So that maybe that you'd find useful. So I'm going to do first name, and then I'm just going to do 1, 3. So it's going to take the first name. It's going to start at the very first letter or number, and it's going to go forward 3 spaces or 3 spots. So let's just take a look at what that looks like. So for our table, it's going to take Jim, Pam, and Tob, or Tobe for Toby. And so it's only going to take the first 3 because you're starting at number 1. Now, what if we started at 3? So we do 3, 3. It's going to go to the third digit or third letter, and then it's going to go forward 3. So you kind of get a sense of how this works. Now, I'm going to show you something that I think is very interesting that I think you guys will also find interesting. Let me fix that because I just messed it up. So if you've ever heard of something called fuzzy matching. Now, if you don't know what fuzzy matching is, I'll give you an example. Let's say in one table, my name is Alex, and in another table, my name is Alexander. If we try to join those two together based off of my name, they will not join because one is Alex and one is Alexander. They're not an exact match. But if I take the substring and start at position 1 and move forward 4 characters, it's going to take Alex from both, and then it will match them together and say that they are the same. So that, it may not be perfect. That's why it's called a fuzzy match, because it can work for a large majority of the time, but it's not going to work every single time. And so I want to show you how we can use this here. Really quick, I need to join this to the demographics table. So I'm going to do that really quick. Bear with me for just 1 second. Let's try to make this at least look somewhat good. So what I'm going to do is I'm going to start off by saying, let's tie it to the first name. Let's do error.first name is equal to the demographics table first name. Okay, so I want to see, and I'm just going to do first name for error, and let's do dem.first name. So let's see what comes up when we do it like this. So the only one that is going to work is Toby, and that's because even though it has a capital O, it's still going to take it. So, we want to get all of them to match. And we can do that, but it's going to be in a little bit of a different way than maybe is perfect, but that's why they call it fuzzy matching. So we're going to use substring on this. So I'm going to say substring. Oops, let me spell that right. So I'm going to say substring, and we're going to go 1, 3. So starting at the first position and going forward 3, and we're going to do the exact same thing on the, substring. Would be great if I could spell that correctly. And we're going to do the exact same thing. So 1 and 3. So we are actually going to take this. Give me a second, missed that. We're going to take this up here, and we're just going to go like that. And why did I copy it with the error? Okay, so let's run this really quickly. And as you can see, it is now going to match all of them. And you can do this on a lot of different things. Typically when I'm doing a fuzzy match like this, I'm not just going to do it on a first name, right? Because there can be a ton of people named Jim. We want to do it on, and real quick, let me actually show you what the originals looked like, just to make sure I hit the point across. And that is going to be first name and come. All right. So real quick, let's actually look at this. So it originally was Jimbo, Pamela, and Toby. In this one was Jim, Pam, and Toby. And so when we just took the first three, because it was Jimbo, it then becomes Jim, it was Pamela, it becomes Pam. Now it matches. And so that's kind of the example that we're going for. Like I was saying, I typically will not just filter on a first name because there's going to be a ton of people named Alex or Jim or Henry or whatever. You're going to do this on many different things. So I would be doing it on things like if I'm trying to do a fuzzy match on a person, I do it on their gender to make sure that their gender is the same. And I wouldn't probably need to use a substring for that, but just to kind of give you a little bit more information, I need to do it on the last name. So I'd need to use that substring again, and I would probably do it on the age. Oops. What am I doing? Come on. The age and the date of birth. Okay, so all of those things, if you fuzzy match on the first name and the last name, and then the gender, the age, and the date of birth are all the same, then you can typically get a very high accuracy in matching people across tables. Whether or not you have, this is an example if you don't have like an employee ID, which is what we do have. But take, for example, we were not given that. This is a way to match them using substrings. Let's move on to upper and lower. All upper and lower is going to do is basically take all the characters in the text and make them either upper or make them lower. So it's very self-explanatory. Let me copy this up here. And we will get going on this one. Let's just look at the first name. Specifically, we're going to be looking at Toby right here. So let's do first name. Let's do lower. And all we have to do is put in the column that we want to do. So this is our original first name. And it then takes every single string that is in here, or every single, character, and it makes it lowercase. That's all it does. And it is the exact opposite when we do upper. So we can now take a look at this one. And now everything's going to be capitalized. So there is a lot that you can do with these string functions. And this is not all the string functions that there are. There are a lot more. But I would say that these are the more popular, more useful ones that I typically use on a regular basis. And so I hope that this has been helpful. I hope that you learned something from this. If you did, be sure to like and subscribe below. I have a lot more videos coming out with tutorials on everything from SQL, Python, Tableau, and Excel. Thank you so much for joining me. I appreciate it, and I will see you in the next video. What's going on, everybody? Welcome back to another SQL tutorial. Today, we are talking about stored procedures. Now, what is a stored procedure? A stored procedure is a group of SQL statements that has been created and then stored in that database. A stored procedure can accept input parameters, and we will be looking at that today. But that means that a single stored procedure can be used over the network by several different users, and we can all be using different input data. A stored procedure will also reduce network traffic and increase the performance. And lastly, if we modify that stored procedure, everyone who uses that stored procedure in the future will also get that update. Let's start writing out this stored procedure so we can look at the syntax. We'll start off very simple, and then in the next one, we'll get a little bit more complicated. So the very first thing that you need to write is create and then procedure. And after that, you're going to name it. So let's just call this one test. And all you're going to say is as, and then you're going to write your query. And so let's just do select everything from employee demographics. And that is it. We have created our very first stored procedure. Of course, this is super, super simple, But let's execute this really quick and take a look at it. So it says that the commands completed successfully. Let's go over to our SQL tutorial. We're going to go over to programmability, stored procedures, and it is not showing up there. What we need to do is we need to refresh our stored procedures. We're just going to go right here. We're going to click refresh, and then there is our stored procedure. Now, how do you actually use this stored procedure that we just created? So let's go right down here, and let's say X, which means execute, and then all we're going to say is test. And we're going to run this, and there we go. So all we put in this stored procedure was a select statement. And so when we actually ran the stored procedure, it returned our select statement. Now let's go down here and we're going to make it a little bit more complicated. We're going to do the exact same thing in create stored procedure. Make sure I spelled that right. And let's call this temp underscore employee. So if you remember from a previous video, we worked on temp tables and we created our temp tables and then inserted data into that. We are going to add that to this stored procedure so we can see the difference between a simple query versus a little bit more complicated query. So I'm going to say as, and then I'm going to insert that in here. Now, what this is doing is I'm creating a table, and then right down here, I am inserting that table. Now, if I create this stored procedure and then execute it, nothing is actually going to be returned. It will insert the data into that temp table, but since I don't have a select statement in this stored procedure, nothing will be returned. So let's write select everything, and we'll just do from, and this is temp employee. And right here, and so now let's create our stored procedure. So that created successfully. Let's refresh over here, and let's execute this. So let's just go down right here and say execute, and it's going to be temp employee. And now we will execute this. And there is our output. Now, really quick, let's go into temp employee, and we actually want to change this stored procedure. So we're going to go over to modify. So when we modify it, a few things are going to show up on your screen. The first thing that you're going to see is it says use SQL tutorial. So it's just specifying the database. The next two things you may not be as familiar with, it's set ANSI nulls and then set quoted identifier. If you don't know what these are, it's not super important. The first one just talks about how to deal with nulls when you're using the where statement. And then the quoted identifier just talks about how it uses quotes in the actual query itself. Again, not super important, but they have those automatically turned on. Let's go down a little bit further and we're going to look at the alter procedure. So we created our stored procedure, but now we want to alter it. So this is the alter procedure, and we are going to add a parameter to this. So what the parameter is going to allow us to do is when we're actually executing the stored procedure, we can specify an input into that stored procedure so that we get a specific result back. And I'm going to show you what I mean by that in just a second, but let's actually add our input, and we're going to say we're going to say job title, and we need to specify the data type that is going to be. So let's just say nvarchar 100. I know below it says varchar 100, but that's not extremely important. So this is going to be our input. So we need to go down here and say where job title is equal to @job title. So when we actually are executing this and we say the job title is equal to, let's say, accountant, this is going to become accountant, and it's going to give us a result based off of it being an accountant. So let's go over here and we're going to click this execute temp employee, which we just modified. And when we run it, we're going to get an error because it is now expecting us to include our parameter of job title. So what we need to do is we need to say @job title, and let's say it's equal to a salesman. Now let's try running this one and see what we get. And so there is our output. If we go back here, I just wanted to show you really quick, we do not have to put this job title right here. You can put this anywhere in the query and use it however you want. That's how parameters work, and that's why parameters are so useful. And you can use multiple parameters for one stored procedure, so you don't have to just limit yourself to one or none. You can put as many as you really like. So I hope that this video was helpful and that you understand stored procedures just a little bit better. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. What's going on, everybody? Welcome back to another SQL tutorial. Today, we are going to be talking about subqueries. Now, subqueries are often called inner queries or nested queries, and they're basically a query within a query. A subquery is used to return data that will be used in the main query or the outer query as a condition to specify the data that we want retrieved. You can use subqueries almost anywhere. You can use it in the select part of a query, the from, the where. You can also use it in insert, update, and delete statements. But in today's tutorial, we're only going to be looking at the select, the from, and the where statements, and you should get a pretty good idea of how to use it in those other statements. All right, now I'm going to paste on screen basically what we're going to be walking through today. But really quick, let's just take a look at the table that we're actually going to be working in, and that is going to be from the employee salary table. And I just want to show you the data that we're going to be working with before we actually get into it. So we have an employee ID, we have a job title, and then we have a salary. So really quick, I'm going to show you what it looks like to have a subquery in the select statement. So let's go down here really quick. And what we're going to try to do is kind of do something like a Windows function, but without actually having to do the Windows function. And so we're going to do this with a subquery. So I'm going to select, and really quick, actually, let me copy this. So we're going to do employee ID. There we go. We're going to do salary. And now we can start building our subquery. So we need to do an open parentheses, and I'm just going to copy this really quick because we're going to be doing it off of that table. So we're going to say select, and then I'll paste that and close it as well. But what we want to do is we want to say average and salary. Now, what this is going to do is it is literally going to run this, and let's run this really quick. It is going to run this and is going to show that the average salary for all the employees is $47,909. So we are looking at the average salary for every employee. So when we run this, it is going to give us the employee ID, the salary, and then in the very last one, it is going to show the average salary for every employee. Now it doesn't have a column header, or a column name. So let's give it, let's say as all average salary. And we'll run that one more time, just to make it look a little prettier. You can also do this in partition by. I'm going to just really quickly write this out. It should take no time at all. And then I'm going to show you why we can't do this without the subquery, why you aren't able to do this with a group by. So really quickly, let me copy this. I'm going to put it right down here. And we're going to say average salary. Whoops. And we can get rid of all this. And we can say over, and we're not going to partition it by anything. But let's run both of these at the same time. And you'll see that they're the exact same outputs. And so it's just a different way of doing it in this example, but it really is just to show a comparison of how you might be able to use a subquery in the select statement. Now you might be wondering why group by does not work for this. Really quickly, I'm going to write this out, and let's get rid of that. And we'll say group by, whoops, let me at least try to write it correctly. Group by, and we'll do employee ID. And we also have to do salary. And then we'll say order by 1, 2. So let's run this. And as you can see, since we have to use the group by, it groups by both the ordered ID and the salary. And so we're not going to be able to get that all average salary that we're looking for, that we can get in the partition by and also the subquery in the select statement. Now I'm going to show you the subquery in the from statement. So let's just get rid of that really quick. And let's say select everything. Let's say from, and we're going to do an open parentheses here. And here is where we're going to write our subquery. So if you have watched previous videos where I've done tutorials on the CTE, or tutorial on the temp tables, this is one that is very much like those, except I think a little bit less efficient. When I'm doing something where I'm creating a table and then querying off of it, which is what we're about to do, I much prefer a CTE or a temp table. Subqueries tend to be a little bit slow compared to a temp table or a CTE. I tend to use temp tables a lot more because you can reuse them over and over, whereas a subquery you cannot. You have to write it out each time. So really quickly, I'm going to show you how it's done, although I don't really recommend using this method. Really quickly, let's go up here and let's steal this partition by really quick. This will be our subquery. And let's paste this in here. I'm gonna make this look a little nicer just so you can visualize it a little bit easier. So really quick, what this is going to do is it is first going to run this and create this table. Again, much like a temp table or a CTE. So let's execute this really quick. It's going to create this table and then it's going to allow us to query off of it. So I can actually say, and let me give kind of an alias to this, a.employee ID, and then let's say all average salary. So now I can take columns from this inner query if I want to and just select those, or I can select everything and return that entire table. Again, I much prefer a temp table or a CTE for this type of situation, but as an example, I just wanted to show you how it works. Now let's go down to the subquery in the where statement, but really quick, I just want to steal this query so that I don't have to rewrite everything. And let's get rid of this really quick and add back the job title. All right, so let's look at this really quick. So we have our table that we've been using, our employee ID, job title, salary. So for this example, we only want to return employees if they're over the age of 30. And as you can see in this table, there is no age column. That is in the employee demographics table. Now, if we wanted, we could join to that table and get that information, or we could use a subquery. And so for this example, we are going to be using a subquery. So let's go right down here and say where employee ID is in, and we'll do an open parenthesis. And now this is where we are going to build out the subquery. So just for visual purposes, I'm going to go right here. I'm going to say select everything, and we'll do from employee demographics and close the parentheses. So we're going to try to select something in this subquery that will then identify the employee IDs that are over the age of 30. So really quickly, let's take a look at this table. So right now we have the entire table selected. So we have the employee ID, first name, last name, age, and gender. So in this subquery, the only thing that should be returned is the employee ID. And in fact, in your subquery, you can only have one column selected. So I can't select everything. I have to specify one column. And that's a little bit different than how we did it in this from statement, where we were basically able to select the entire table and then in the select statement specify what columns we wanted. In the where statement, we can't do that. So we want to return the employee ID, and we also want to say where the age is greater than 30. So let's run this really quick and see if it works. As you can see in the results, these are the employees who are over the age of 30. Now, if you wanted to display the age as a column in this output, you would have to join to that table and then put that column or that field in the select statement. But in a lot of situations, you won't actually want or need to do that. And so a subquery can be a really good option in these scenarios. With that being said, this is the last video in the advanced SQL tutorials. I hope that this series has been helpful and that you learned something along the way. Thank you so much for joining me. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video.